Electricity. When you think about electricity, you usually think about flipping on the light switch or turning on the oven or the TV. But today we're going to talk a little bit about other kinds of electricity in forms that you probably never even thought about. Some of you may have heard of potato clocks or lemon clocks. You can buy little kits that have all the things in them, or you can make your own. It contains a zinc little rod and a copper rod, and you need two of each, and then obviously electrical wires in between, and something for it to charge. Most people use a little clock. That's what I'm using today. So we're going to start with lemons, and we're also going to do potatoes because you can do either. Now what happens is that I'm going to take, you can see the zinc is a silver color, and the copper obviously is a copper color. And it's going to take 2 lemons or 2 potatoes to be able to charge enough electricity to make the clock come on. So we've got the copper in 1 lemon and the zinc in 1 lemon. And then I have 2 other rods that are connected to the clock. And we're going to do just the opposite of what we've done here. So in the one with the zinc, I'm going to insert the copper rod, and then if you'll focus on the clock, as soon as I put the zinc one into this one, all of the connections should be made, and we should see the clock come on. So here we go. Electricity. Now, I'm no electrical person, so let me talk about exactly how that works. The metal strips and the potatoes, or the lemons in this case, make a simple battery that creates the electricity to operate the clock. Each potato or each lemon works as a device called an electrochemical cell. It converts the chemical energy stored in the metal strips into electronic energy. 2 potatoes are needed, or 2 lemons are needed, to make the electricity strong enough to run the clock. A cell works because the chemical properties of the metals inside, in the case of the copper and the zinc, the different properties cause tiny particle charges with electricity called ions to move between the 2 strips of metal. This flow is an electrical current. The potato contains the particles that allow the current to flow, but to stop the metals touching, it stops the metals from touching. Current electricity also flows along the wires between the copper and the zinc and the clock. The current makes the clock work. So, pretty cool. Now, let's do the same thing with potatoes so that you know that I'm telling you the truth, that you can do potatoes. So, we'll put the 2 connections together. Obviously, we've got a circuit here between the 2 things, 2 metals, and then we're going to take our other 2 inserts here. Again, we're going to do the zinc with the copper so that you've got the opposite, the same thing here. And as soon as I touch that, then you've got electricity and a clock that works.